Hello everyone, we're going to continue on with Newton's Law. So this is PowerPoint number 2 with Newton's Law. And we're going to talk specifically about friction this time around. Friction is a force that brings moving objects to rest. It literally acts against the direction of whatever the motion is happening. If friction happens to be absent, then the direction and the velocity of motion continues on forever and ever and ever. And that's what we think of when we think about space and things moving in space. They move on forever and ever and ever. And that's because there's a lack of friction in space. So they tend to move on forever and ever and ever. Okay, so this is a video that has to do with experiment 10.2 on page 235. Before you watch the video, write down your hypothesis as to where you think the marble is going to go. Is it going to go in direction A, B, or C? If you look in the book, it'll show you which direction A, B, and C are. So basically, you're kind of predicting where the marble is going to go. And then watch the video and then begin a lab report. You're going to write a formal lab report just like we've done in class before over this video. And then I want you to upload that to the homework drop on Monday. So once I finish, go ahead and write your hypothesis down and then watch the video and write a lab report.
I've got a quick demo for you here. What I'm going to do, I've got a pie pan with about a quarter of it cut out, and I've got a marble here. I'm going to take the marble and give it a push so that it rolls around the outside of the pan, but this time I'm not going to stop it. So I'm going to give it a push and let it roll here. I want you to make a prediction as to what will happen. Okay? Do you think that the marble will keep going over the gap and just continue in a circle? Let's call that option A, if you want to choose that one. Do you think the option B is if it goes off here in sort of a straight path? Or option C is if it sort of travels away from the circle that way. Okay, so take a second and think about what you think is going to happen when I release this marble and let it go into the gap area there. Alright, I'm going to go ahead and see how it goes here. I'm going to put it here and give it a little push. Do it one more time in case you missed it. It does travel in a straight path. Okay, so option B was the correct one. Nice job if you guessed that one. This is having to do with the inertia of the marble. So as soon as it's traveling around this way, there's an outside force, which is the side of the pan, that's keeping it from traveling in a straight line. As soon as it gets over here, the outside force is gone. So the marble wants to travel in a straight line. Okay, it has to do with Newton's first law, which says an object in motion stays in motion, and an object at rest stays at rest, unless acted upon by an outside force. So as soon as we get here, there's no more outside force, so it stays in motion, traveling in a straight line. Okay?
Okay, so friction is our next topic. Friction, of course, is what Newton's first law calls that outside force that we've been talking about. Friction is technically an invisible force that causes objects to slow down or stop, and it keeps an object from starting to move in the very first place if it's not moving when you first observe it. So if friction didn't exist, then objects in motion are going to stay in motion forever, like we talked about in space. The strength of the frictional force between two objects depends on the physical characteristics of the object. So friction is that force that exists whenever two surfaces are touching each other. They have to physically be in contact with each other. And so on the atomic level, there's really no such thing as a smooth surface, even if the surface looks and feels smooth to us. there's still some atomic attraction between the two objects. And the more they attract each other, the more friction you're going to have and the more they're going to resist motion. And so basically friction is a force that opposes motion. It keeps motion from happening, and it results from the contact of two surfaces. Again, here's another experiment that has to do with friction. This is experiment 10.3 on page 237 and 238. I would like for you to watch the video, and then you're going to do a lab write-up and put that in your ISN. At the very end, it's not the best video to kind of end this, but I think you'll get the idea of what's going on in the video because it was the best video I could find. So here you go.
All right, we're doing experiment 10.3 in physical science, measuring friction. So we've got a log, an eraser, an ice cube, and a rock, and we're going to see what it takes to get them down the board. So we're going to raise this up, see how high it gets. Alright, at 16 inches, the log and the log and the rock are starting to slide, and there goes the rock. At 17 inches, okay, 17 inches. 18 is the eraser, 19, 20, 21, 22, 23, ice cube still not going down. Gosh. It gets stuck. Wow, I can't believe that. Okay. There you go. Alright, so in the second part of this experiment, basically what you have to do is sand this board right here that you've got to reduce friction. So we're going to see how high we have to go before the things slide down. Alright, so we'll start lifting the board. Okay. 14 inches for the eraser and the rock. 16 for the log. I believe this ice cube is stuck. Okay, well that fell down too. We'll take that ice cube again. Alright. It fell down almost immediately. So, yeah.
Okay, so I kind of wanted to explain a couple of things about the ice cube at the end. He kept having to move it so that the ice cube would actually fall. What you're actually seeing there is the attraction of the water molecules to each other. They're attracted to the board. Remember, as ice melts, it becomes a liquid. And remember, when we talked about liquid water, the molecules will literally have an attraction for each other. And that attraction is pretty strong. And so what you saw there was the attraction between the liquid water and ice water molecules attracting to each other to keep that ice cube in place. So that's why I said the end is kind of a little quirky, because he starts moving the ice cube around. And in the first trial, the ice cube went all the way up and it didn't fall at all. And he said, that's kind of curious. Well, that's why it didn't fall, is because water molecules have a huge attraction toward each other, and it keeps the water kind of, if you will, quote unquote, sucked to the board so that it doesn't fall. So just kind of an interesting little tidbit there.